side is opposite angle A now? What side is opposite angle A? What's the side opposite? Name it. 8.
CB.
CB, good work. Now adjacent. Now, I get it. You could give me 2 sides that are next to angle A. But when I'm asking for the adjacent side, I'm looking for a leg. Because I already took care of that other side. It's called the hypotenuse. So when I ask for opposite and adjacent sides, you give me the legs. And there's only one more left, right? The adjacent side to angle A would be AC. Okay? So when you give a side that's adjacent, you give a leg. You don't give the hypotenuse because that's already the hypotenuse. Now look at angle B. Now look at angle B, everybody. Go ahead. Figure out the sides I'm looking for using B now. Okay, I'm using angle B. What's now the adjacent, opposite, and hypotenuse? How about the adjacent side? Actually, you know what? Let me start with the hypotenuse again. 21, what's my hypotenuse? Still AB. What's the opposite side to angle B now? Opposite side, 11?
AC.
AC, good. And the adjacent side, process of elimination, right? CB or BC. All right, so we can identify those. All right, why do I need you to identify those? This is going to help you with our new ratios I'm going to introduce right now. So none of the stuff I showed you last week works anymore. I just don't have the information or the diagram to do it. So I need something new to find the side. So what I'm going to introduce to you today is 3 brand new ratios you've never heard before. And remember what a ratio is. A number over a number. Right? That's what a ratio is. A number, a value over another value. Kind of like a fraction. So let me introduce those 3 ratios to you now. First, I just want to introduce a little friend here. That's called theta. It's a Greek letter. It's a variable. It's a variable. What variable do you guys usually use over and over again? X, right? That's the same thing. Means the same thing, but usually we use theta when we're talking about an angle variable. All right, so all that is an angle. Okay, that's all that is. I would not be concerned about it. All right, I just didn't want you to freak you guys out that you saw it and I didn't mention it. All right, let me introduce you to the first ratio today. The first ratio is called the sine ratio. It's actually, this is how you spell it, S-I-N-E, but we abbreviate it when we write it S-I-N. It's not sin. It's not sin. Sine. Sine. How do you find the sine ratio? Ready? You take the opposite side and put it over the hypotenuse length. All right, so whatever the length is of the opposite side of your angle, you put that over the hypotenuse length. That's how you find sine. Okay? And I'm going to go through these a little quick, and then we're actually going to slow down and practice the heck out of them. The second ratio. How do you think you say this? Cosine. Yep, cosine. But when I write it, I abbreviate it COS. Cosine. Sine, cosine. How do you find cosine? Ready? You take the adjacent side, whatever how long that is, and put it over the hypotenuse length. Good? Last one. How do you think you say this ratio? Yes? Tangent ratio, abbreviated TAN when we write it. How do you find the tangent ratio? You take the opposite side and put it over the adjacent side. And these are all going to be numbers. Okay, these are all going to be lengths of the sides. Okay, it's just so you know, opposite means the length of the opposite side I put in. Now, I just threw a lot at you right there. And my first thing is, how are you going to remember all this? Right? How are you going to sine is the opposite side over? I'm going to get this confused. And I don't blame you. So I got a device for you, like Hills and Sass. I got a device on how to remember this. Anybody see Pocahontas before? Movie, cartoon, Pocahontas. It's okay to admit, it's fine. Do you know, it was not put in the movie, but Pocahontas had a brother. Anybody know that? She had a brother. And luckily, her brother's name helps us remember what goes with what. Her brother's name? SOHCAHTOA. Her brother's name. How many of you are believing that? All right, we'll see. All right, you can do your research later on. Her brother's name, SOHCAHTOA. How does his name help us remember what goes with what? Everyone ready? The S stands for sine. How do you find sine? What do you think the O stands for? Opposite over H. There you go. Sine equals opposite over hypotenuse. C for cosine. How do you find cosine? You take the adjacent side and put it over the hypotenuse. And then finally, T for tangent. How do you find tangent? You take the opposite and put it over the adjacent. The only thing you got to remember, how do you spell the name, right? All right, it'll always be up there, I'm sure, so you can cheat. God forbid you remember how to spell SOHCAHTOA. All right, but it'll always be up there. So that's how you can remember the ratios. All good? You ready to find some now? Jonathan, you ready?
Sure.
How about your group?
I don't know about that.
Okay, good talk. You're honest. Here's what I would like to do right now. I want to use triangle ABC right here. It's got 22, 18, and 13. I'm not even going to go over the steps. I'm just going to go get after it right now. The first thing I want us to find is the cosine of angle A. Find that ratio for me. We're going to do this together. Find the ratio that represents the cosine of angle A. So the first thing you ask yourself is, what's the cosine ratio equal to? You can look back at SOHCAHTOA. C for cosine, it's equal to adjacent side over hypotenuse. The adjacent side over the hypotenuse. You're looking at angle A now. Look at angle A. What is the side length that is adjacent to angle A? 5? 18 over the hypotenuse of this triangle, which is how long? 24? 22. Good. So there's the cosine of A. That ratio is 18 over 22. No, you don't need to reduce it. You can if you want, but I'm not going to require it. Let's find the tangent ratio for angle B. The tangent ratio for angle B now. So I look back at SOHCAHTOA. Tangent is the opposite side over the adjacent side, but now everyone's looking at angle B. Okay, everyone look at angle B right now. What is the length opposite angle B? 20? 18 over what's adjacent to B? 16? 13. 18 over 13. There's your ratio. One more? Sure. Do the sine ratio for angle B now. What's the sine ratio for angle B? So you look at SOHCAHTOA, opposite over hypotenuse. What's the side opposite B? 16 again. 18 over hypotenuse. 21. 22. All right, there you go. Questions finding the ratios, because we're going to need the ratios to solve the problems now. I would have a question if I were you guys, but maybe not. Why did I pick only A and B? Why did I leave C all alone and not even say find the tangent of C or the sine of C? What do you think, Audrey? What do you think there, Serena?
There's two adjacent sides?
Yeah, well, when I say adjacent, what are you going to pick? And when I say opposite and hypotenuse, what's the problem? It's the same, right? So we will never go from the right angle. I will always ask you to look from the two acute angles, all right, that are not the right angles. All right? Questions? All right, ready to use it to find a side now. Here we go. Let's go. We can read through the darn steps on your own if you get confused tonight on homework. Let's jump right into the fire, example 1. Find x to the nearest 10th. Ready? First, before I show you, can we go over why last week is no good here? Why can't I do Hills and Sass? Why can I not use Hills and Sass here? No altitude. Good job, Brendan. No altitude. Why can't I use Pythag? It's a right triangle. Why no Pythag, guys?
No, 2 sides.
I don't have enough info, right? I do 15 squared plus a variable squared equals another variable squared. That ain't flying. Don't take this too seriously. Why can I not use my 45-45 or 30-60-90 rules?
We have a 36-degree angle.
I have a 36-degree angle, and that's not one of my triangles. So everyone all right? Why? Nothing I showed you last week worked. So now what we're going to do is use what's called trigonometry, sine, cosine, tangent. When you hear someone say the term trigonometry, that's what they're talking about, sine, cosine, tangent. All right. First thing, we always go from, we don't need to, but it's easier to go from the angle that you're given. So everyone look at angle B, 36 degrees. Identify right now the other two sides that are written in for you. What is the 15 side and what is the x side? What do we call those from angle B? All right, see if you can figure that out on your own now. What do I call the 15 side and what do I call the x side? I don't care about BC because it's not labeled. I don't care about it. I want the two sides that are labeled. All right, what do I call 15? That's what to be. 4, Griff? Opposite. And what I like to do, and I'd like you guys to do just at the beginning because you're rookies, is put a little O in parentheses that says, hey, I have the opposite side. And what's side X? What do I call that in the triangle? That's 1. Meg? Side X. That's the hypotenuse, so I'm going to put an H there next to it. Now you decide which ratio do you have enough information to use. I have the opposite and the hypotenuse. So go through SOHCAHTOA if you have to. Which one of the 3 ratios do I have enough information right now to use? When I have the opposite and the hypotenuse now. I have opposite and hypotenuse. Which ratio am I choosing to use here? 12?
Sine.
Sine, because look, I have O and H, opposite and hypotenuse. So everyone's good. We're about to use sine in the problem. Everyone all right? Why I selected that versus the other 2? I know nothing about the adjacent side, so I'm not even going to sniff these 2. So we're going to use sine. Right now, let's build the equation. Sine ratio. Ready? Sine, S-I-N, abbreviation. Now instead of putting A and B here, I actually know the angle measurement to plug in. What is the angle we're using? 36. So instead of putting A or B here, guys, I'm going to put sine of 36. I know it. It's not a letter anymore. I actually know the degree measure. That ratio, sine of 36, is equal to opposite over hypotenuse. What's the opposite side? 15 over the hypotenuse, which we labeled. You have the equation to solve now. The sine of 36 is in the same ratio as 15 over what? All right, honors kids, how do I solve it now? What do you think? How can I get x by itself here? Here's a hint. We've done a lot of these last unit in similarity and Hills and Sass. Hi, Avery.
Proportion.
Put the sine of 36 over. How do I solve it now? Cross them up. Cross them up. Here we go. I'll do it with you nice and slow. This is all new, guys. It's okay to feel uncomfortable. Sine of 36 times x. Let's write it. Sine 36 times x equals 1 times 5, 15. We're solving for x. How do you think I get sine of 36 out of there? Yeah, divide it out. Stay with me. Divide by the sine of 36. Divide it out. So x is going to be equal to whatever 15 divided by the sine of 36 is. And good news, this is all calculator now. Okay, everyone grab your calculator. There's something we have to do before we go. Grab your calcs. Can you please first go to your mode button? Everyone see where your mode button is up here with me? Your mode. You never knew this, but there's two ways you can measure an angle. What you're used to, which is in degrees, right? And then there's also another measure, which is called radians. We won't touch radians until like unit 10. This is what? 36 degrees. So you want to tell your calculator, I'm about to plug in degrees, so you better be in degree mode, calculator. So I want to make sure, if it's not already, make sure I highlight degrees and press enter. That's what your calculator wants to be in the entire unit, degree mode. We aren't going to discuss radians until later on in the year. So your calculator in degree mode, you guys, beast mode. Got me there? Got that flow, how that worked? Good. All right. Is on all the time. So now go to your calculator. I need to figure out what 15 over the sine of 36 is. So everyone get a fraction template up. 15. And here are the new buttons I was talking about. Everyone see these row of 3 here? Sine, cosine, tangent, right next to each other. So I want to do sine. What's my angle? 36. So inside the parenthesis, 36. Sine of 36. That's a number. Your calculator knows that number already. And then, there we go. And now I just got to pay attention to my rounding directions, which I believe here is nearest 10th. Yep. So what are we looking at? 25.5. Last thing, and I know I'm piling on a lot for this first problem. This I never made an issue about it because it's never occurred this year, but it will right now. I'm going to make an issue about it. And because you're in honors, my answer is naked. Why? If your darn problem has units in it, so does your answer from now on. Or yes, it's going to be some points off, unfortunately. All right, half a point every time. Put the units with it if it came with units. All right. All right, that took me a long time to do one problem because it's brand new. We'll pick it up right now. Okay, let's pick it up. Go, Caitlin, yeah, sure.
What is the sine and the cosine tangent? Like what?
Okay, good question. Good question. It's actually the sine. Let me show you right now. Let me put it. Don't touch your calculators. I just have to do this. Okay, the sine is actually it's a graph. Okay, let's see. Zoom. Let me show it to you. 7. That's what the sine curve looks like, right? And down here are all your x values. So when I ask you to do the sine of 36, your calculator is going to 36 along here, and then finding out what the y coordinate it corresponds with is here. Okay, so do you see this is 1 right here? Okay, so watch. Let me go back to my calculator. Actually, why don't you do it, Caitlin? Do sine of 36 in your calculator.
Put it in.
Yep, just do sine of 36 and tell me the decimal. You're going to get a decimal out, which is what?
0.5.
Yeah, so sine of 36 is probably right about here, and here's its corresponding y value right here, which is about 0.5. So that's what your calculator's doing to get those numbers. Cosine, totally different curve. Okay, tangent, totally different curve, but your calculator is going to go to where you ask it to on the x-axis and find what the y value is. Okay, last thing, just to prove my point, do cosine of 180 in your calculator. No, sine of 180.
0.
That's where take a look at my graph. That's where 180 is. And see how it's at 0? So that's what it's doing. Is that all right? Good explanation? Okay. Everyone always asks that every year. Yep. Where do they get these values from? All right, next up. My next right triangle here, I see that's 48. So can you guys please label going from 48 what the x and the 37 are? What are the x and the 37? And then we got to figure out what ratio to use. All right, what's the x here? What side's the x? How do I label that? 17?
It's adjacent.
Darn right it is. And how about the 37? 21? Good job, everybody. So I have adjacent and hypotenuse. Look through SOHCAHTOA. Which ratio do I have enough information to use now? 23? Cosine. Good. Thank you for not calling it cos. Cosine. So ready? Cosine. But I'm not going to put V in there. I know what angle V is. It's 48. The cosine of 48 equals, remember cosine, A over H. Adjacent X over hypotenuse 37. Just like last one, turn it into a proportion. Put it over 1. Now you'll see something interesting here as we solve this. Cosine 48 times 37 equals, what do I have on the other side? Notice there's nothing to divide out this time, right? Unlike the last one, and that'll happen depending on where your x is. Are we okay? So nothing to divide out. Now I go to the calculator. All right, go ahead, go to the calculator. Just one thing I got to warn you about. So I do cosine 48. Everyone see where I am right now? Close it. I don't want to do this times 37 because the calculator is going to think, oh, whatever 48 times 37 is, you want me to take the cosine of that. No, I don't. I only want you to take the cosine of 48, then multiply it by, it was 37, right? 37. Boom. There you go. And what's this rounding to here? 24, 25 inches, right? Nearest inch. So how do you feel now? A little brand new math here, huh? Quan, you doing all right?
Yeah.
What about the all-state group over there? Okay. All right. We'll see. All right. Let me throw some, I don't like to call them word problems, but I guess they are, huh? Classic problem with sine, cosine, tangent. My old ladder leaning against the wall. A window of a house is 15 feet above the ground. Nice job. Ladder is placed against the house with an angle of 75 degrees with the ground. Yep. What's the length of the ladder to the nearest 10? What side am I finding here? Length of the ladder. And by the way, it was leaning against the wall. It was leaning against the wall. Where's the ladder? The other leg or the hypotenuse? Oh boy. Leaning against the wall. The hypotenuse, right? This is what I'm looking for here. Your ladder is always the hypotenuse. And I just gave that away, so I put an H there. How about the 15? What should I be labeling the 15 as in this problem? Look where the 75 is, of course. 14. I don't think we have one, do we? That's the magic number. 5. Oh, we got a 5, Greg. Opposite. Good work. So you have the hypotenuse and the opposite, which is 21. Which ratio can I use? Sine. Good work. Sine of the angle 75 equals, what's going to go on the right side now? SOHCAHTOA. OH. What do you got? 3?
O over H.
Yep. Go ahead, fill in the values now for me, even. It's all right.
15 over X.
You weren't wrong. 15 over X. Good. Over 1. Cross multiply. Sine of 75 times X equals 15. Now, this is one where I do have to divide both sides. So divide both sides by the sine of 75. And then now I go to my calculator. 15 divided by sine of 75, and nearest tenth of a foot. Or nearest, yeah, tenth of a foot. .5 units. I know it's going to take a while to get used to that. Feet. The problem, hey, and by the way, if the problem doesn't have units, don't give me the little U there. No thanks. Or write units. I'm good. Just leave them off. Thank you, though. I appreciate your attention to detail, but just don't even put any. All right, you and your group, number 2. Go ahead, nearest foot. Here we go. Back to you guys now.
Opposite of the hypotenuse. Jason. Oh yeah, so both sides. Oh wait. They just use different angles. Jason. Oh, you're right.
18 feet. As we keep working, 18 look good. Using cosine ratio. 18 feet. Questions, comments? Okay, I'll do this next one here, number 3 with you. Which ratio is equal to the sine of angle A? So I'm thinking sine now. Sine. What's sine equal to if I use what 2 sides? What is the sine ratio equal to? 10?
It's opposite hypotenuse.
Good, opposite and hypotenuse. Now, you'll notice here, there's only one right angle. So how do I know the smaller triangle is also a right triangle? Not because it looks like it, Mr. Carlino. Let's go, Charlotte.
Because BC and DE are parallel.
Yep, keep talking.
Angle DEC and angle DCA are corresponding perpendicular.
Parallel lines mean corresponding angles are congruent. Good, so the little one is also a right triangle. So everyone ready? Angle A in the little triangle is opposite what side? Good, anybody? BC. What's the hypotenuse of the little right triangle? AB, which happens to be choice 3. Now, let's say that wasn't up there. How else could I get a different answer? That's still correct. Come on, I'm going to challenge you here. All right, BC over AB wasn't a choice. So use what instead now? The big right triangle. What would be my answer then if I use the big right triangle? What's opposite angle A there? Opposite is DE, and the hypotenuse is still, not still, but I'm sorry, it's not one job. Act like you've been here. Would be what? AD. So everyone see, both answers are correct there. Just one happened to be a multiple choice. Questions? Oh, you wanted a little Big Al, little Mike? Yeah, you missed them. They're arguing again. What a shock. Big Al's like, whoa, I want to find HJ. So Big Al says it's equal to the sine of 28 equal to HJ over 20. He's like, no, this is how you find HJ right here. Do this. Is he correct? We're not looking for HJ. I just want to know, is that a correct way to find HJ? Well, let's see. Sine is what? Opposite over hypotenuse. So if I'm going from 28, somebody let me know, what's opposite 28? What's hypotenuse in that diagram? Is he correct? Yeah, you can find it that way. Yeah, Big Al's correct. What about his little bro? Cosine. Wait a second, little Mike. Where is he getting 62 from? Where's that coming from? 62? Tammy? That's angle H, right? 180 minus 90 minus 28. Yeah, 62 is angle H. So little Mike's using a different angle other than the one he's given. He just wants to show off, obviously. He's saying that's HJ over 20 as well. I don't know. Is he correct? Cosine. Cosine. Adjacent. What's adjacent to 62? HJ. So that's correct. Over hypotenuse, which is still 20. So A over H. Both of them are correct. Everyone see why? Yeah, two different ways. Just went from two different angles instead. Studs only need to do number 5. So put your pencil down if you don't fall in that category. Studs only, number 5. Ladder leaning against a building. All right, we know what that looks, right? We got right triangle. Where am I putting the 4 feet? Thank you. It forms a 71-degree angle. Oh, this guy. With the ground. The ground. Not the ground. The ground. Where am I putting this 71? On the bottom or the top? On the ground. Right? 71. How high up the wall does the building does the ladder reach? Which leg am I finding now? The horizontal or the vertical leg? How high up the building it reaches? Vertical. Oh, jeez. And that's not even the stud part of this problem yet. All right, find out what ratio we need. I got hypotenuse 4, opposite x. What ratio do I need here? 22? I got opposite and hypotenuse. Which ratio do I need? Sine ratio. Set it up for me. 21 sine of equals over 4. Some of you are wondering where the stud part comes in. You're like, this is easy. We've done this all day today. You're right. All right, go ahead, cross multiply. Sine of 71 times 4 equals x. We all go to the calculator. Look at me, I'm a stud. Sine of 71 times 4. That's my round to the nearest tenth. Hey, 3.8, we're good to go. What's the problem, though? Who cares, right? That's an easy problem, Mr. Carlino. All right. I'll wait. That's not my answer. I'll wait. What do we got left? 4 minutes here. We don't have too much time, but I'll wait. Think you got something for your classmates, Jonah?
Yeah.
That we need to be more detailed readers starting today. Why, Jonah?
Because the 3-point, like, whatever it was, is in feet, and we need to get it in inches.
Directions. Round to the nearest tenth of an inch. The ladder is in feet. All right, so my answer right here is in feet. Okay? My answer is in feet. How do I get it into inches? Multiply it by 12. Correct. Got to start being aware of that. I'm going to try to trip you up anytime I can get it. So now I can round this and get 45.4 inches. If you notice that at the if you notice that at the beginning of the problem, can I change 4 feet to inches and do it? Yeah, you can. That's fine. You're either going to do it at the beginning or at the end, but please start being aware of the change in units. It will happen a lot. We got plenty of time for you to do number 6 to finish up class. I'll just throw the answer up here. Again, are the directions the same as what I give you as far as the units go? Start paying attention. Centimeters and centimeters, so you're okay on this one. Keep going here until you get BC equal to 3.3. Why are we using angle B as your 90 degrees? Can't have two 90-degree angles in a diagram, right? Can't have two 90s.
I usually do bookmarks on my phone.
Have a great night. And
I'm so scared of that.